Hey guys, this is Austin with Bullard Innovations. I just wanted to show you our nesting protocol for Hyperdent. So we do add user-defined areas to all buckle surfaces of the iBar. This case in particular has 3 individual overlapping user-defined areas. We place those in areas that are undercut or might be difficult for the mill to get to. We identify each of the screw types manually. We also place sprues, one on each heel and then one at each implant site along the lingual and below the margin. The idea here is to have no sprues on the area that is going to be cemented to. One thing that can help you achieve milling all of the areas of the iBar sometimes can mean rotating the part, so bringing this buckle surface a little bit up to allow the undercut angle to be less and easier to achieve by the mill. One thing that we do every time is calculate the job and then run the tool paths so that we can see the result. So I'll show you guys that here in just a second. Okay, so our part is calculated. Once your part is calculated, you can right-click on the part and go to Show Toolpaths. This will bring up what we call Hyperview. This is the simulation software for Hyperdent. It's currently loading all of the toolpaths, so the yellow lines are the actual milling movements, and any of the red lines are just movements where there's not material being removed. So once it gets done calculating these toolpaths, we will then calculate the result. Once all the toolpaths have calculated, you can see them listed here on the left-hand side of Hyperview. Each of them has a light bulb next to it, so you can turn on and off individual toolpaths. But what I like to do is turn off all the toolpaths by clicking the light bulb to the left of the toolpaths section. That will turn off all of the toolpaths, and then come up to Result, right click and calculate, and let this operation run. Okay, our result is calculated in Hyperview, and what you're looking for or looking at, the red is the STL and the gray is the result from Hyperdent. So you're looking around this object and trying to see that all of the material has been removed and matches the STL. When you're looking at this result, make sure you're looking at the buckle surface where your user-defined areas are, and make sure that that area is not gray. Gray would mean that material is being left behind. This arch here, the results are very, very good. Some of these areas that are all gray or all red, actually that is the STL and the result matching exactly. So we have a good result here from our mill. Things that I've noticed is that sometimes there is a flat wall on the buckle surface where Hyperdent didn't send tools in here to remove the undercut. And that's undercut not in the design, but it's undercut relative to the top surface of the puck. So for our office, we calculate the results of every job before we mill them. You'll also notice that the sprues are on areas that are not going to be cemented to. So again, these parts should fit directly out of the mill.